Hello and welcome everyone. Let's dive into some code in this video. And what we want to see is this interaction. We want to see V1 chat completions interaction that happens from the chat endpoint, which is at the Fast API backend server, to the Ollama endpoint, which is the V1 chat completions, right? Which is residing in the Ollama server. So in order for us to see this, we first need to see how Ollama server in general responds back to any request. And anytime when I say Ollama server, I mean Ollama interchangeably with OpenAI because they both at the V1 chat completions endpoint comply with the same request response format, right? So let's take a look. All the code that I'll be showing to you today will be in my repo. So if you go to github/teachings, and there is a basic agent chat, which is like the overall repo for my main application. But in this video, I'll be diving into Ollama native tool calling repo, right? So if you go click over here, this is the code that you will need for understanding today's video that we are going to talk about. All right, so I have actually already cloned this repo, and this is one file that doesn't exist yet. Maybe I will check in, but it's a very basic file that shows you the initial interaction that you do with your Ollama server, right? So let's see what is going on over here, and let's do some of those interactions. So at the very high level, whenever we are trying to interact with Ollama server, we need a few details. What are those? We need the API endpoint. So the API endpoint in your case most likely would be localhost colon 11434. In my case, it is localhost. Instead of localhost, it is ai.mtc/LAN because this is my basement server that is in my basement, and this is the one that I'll be using right now. But in your case, it is localhost colon 11434 if it is in your local laptop or computer that where you are running this. Now, V1 chat completions is where this chat completions endpoint is exposed. So please make sure to add this also to your API URL, right? Also, there is a model that you want to provide. So you need to download this model, whichever model you like. Llama 3.1 is what I'm using. If you're using an 8B model, then I would highly recommend to use the Instruct Q8 quantized version of it. I've noticed that the regular, not the Q4 version, quantized version doesn't perform well. So the Q8 quantized version is pretty decent as compared to Q4. Now, one of the best models that I have tried for this use case is Llama 3.1 70 billion parameter model. So if your VRAM can allow, if you have about 42 gigs or 44 gigs of VRAM, in that case, you will be able to use the 70 gigs, right? So if you have two NVIDIA 3090s or two NVIDIA P40 cards or 4090s in that range, if you have a high-end system that is capable of doing it, then for sure you should be utilizing the 70 billion parameter over 8B Q8, right? So all that being said, your Ollama server or any OpenAI compatible endpoint will require a few details, right? So your server endpoint, an API key. So in Ollama, you don't need that. You don't need an Ollama key, right? So you can just provide any fake key. In my case, I have just given this text. But for OpenAI, you will need this key. So you need your API URL, you need your API key, you need a payload, right? So payload is what you'll be delivering over here. So when you do a post request, you need to have some kind of payload that you are sending to that post request, and then you receive a response back based on it, right? So this is your API endpoint. This is your payload. In your payload, you have a model that you are describing, and you have a message, a list of messages, right? So there is an array, and in this array, there is a list of messages that you are sending. So in this list of message, this is how you structure your message. So if you go back over here, I was talking about when you structure your message, you have a system message, user message, assistant message, and like that, so on and so forth. So there is only one system message per context, right? So you will have only one system message, and then you will have multiple user messages, multiple assistant messages, multiple tool messages, and all that. But there will be only one system message. And normally the order that follows is one system, then user, then assistant, then user, then assistant, user, assistant, and it keeps on going. And if there is a special scenario where there is a tool call, then there will be system, user, assistant, tool, assistant, and then user. And then that is the scenario that will follow, right? So it will loop through after that. So if there is no tool call, right? So let me just copy this over here and make two different scenarios for us. So one is a tool call scenario and one is a non-tool call scenario. So in a non-tool call scenario, this is how it works. So you'll have a system, user, assistant, and then the conversation keeps on going. Whereas if it is a tool call scenario, then you have a system, user, assistant, tool, assistant, user, assistant, tool, assistant, user, right? So it keeps on going like this. So this is what repeats. And then you will have a user again after this, and then continued, right? So, and a user over here, and then it continues like that. So a conversation in a tool call, so this is a simple conversation, and this is a tool call conversation. And I'll talk about what these two are. Once I show you the code, you'll make sense of all this. But this is in the very first example, I'll show you how we are setting system and we are sending a user message and how we are getting the response from the assistant over here, right? So let's open the terminal over here, new terminal, and let's run this Python code, right? So we are in the right folder, and let's run this particular Python code that we have. So Python, and the name of this file is test.py, and let's send this. So as the very first time, it is loading the model in the backend, in the server, Ollama server, and it is sending a response back, right? So what I've said is that, hey, you're a serious AI assistant who is very reserved, only respond in one or two words. So let's see what the model response is. So this is what the model sent back as the response, right? And there are a lot of details over here. The important information is you will see a message, role assistant, and content hello. So this is what the model told back, right? Told us back that, hey, this is it. So if you want to continue this conversation, right? So you have your role system, role user. And if you look at this conversation over here, system user, and the response you got back was from assistant, right? So you have the role assistant response back right here. So if you copy this, right, let's copy this part and let's paste it over here. And this is what that continuing a conversation means, right? So you copied that and you are telling in the next request that this is what assistant had said, and now this is what you are going to reply back, right? So original message was system prompt as this, user said hey, assistant said hello, and now what you are going to say, let's say how are you, right? So now you said how are you, and you're gonna send this back by executing the script again. So now you're going to take this whole payload and then you're going to send it to this API endpoint, right? So this is what we're talking about. Now we have constructed the message system user. We got the assistant reply like this from the assistant, and then we are taking that assistant reply and copying it over here in our code, and then we are putting our user question back in there, right? So now we are putting our user question back in there, and whatever we get back from user, we will paste it in our code, right? So let's run this again and see what we get back from user, from assistant. So this is what we got back from our large language model. Let's see what it says. Content fine. Wow. Okay, so it is really reserved, right? So it just said fine. Let's copy this back over here. Let's paste it over here, and this is the assistant saying fine. And then now you can talk back to it and say, my name is Mukul, and let's see what the AI model says. And it said acknowledge. Wow, so it is being really reserved, right? So let's copy this and let's paste it over here, and let's ask it what is my name. Ask it what is my name, and now it will refer back to this chat conversation history, and hopefully it will respond back with my name is Mukul, right? So let's save this file again and let's run this again. Okay, so now it says in just one single word that my name is Mukul, right? So it is continuing the conversation. And this is the point I was trying to make, is that in a very simple scenario, right? So this is a very simple scenario where there's a system, user, assistant, user, assistant, user, assistant, user, assistant, right? So that kind of scenario, system, user, assistant, user, and it keeps on going, and this loops keep on going, right? So we are having a very simple conversation with the large language model. We are building this conversation on the fly using, well, in here we are manually building it, right? So we are manually copying the response back over here, and we are manually building it. But in some kind of application, right? So in the application that we were looking at earlier, over here in a AI chat based application over here, this your slash chat endpoint that you had, this particular slash chat endpoint was doing this for you. So instead of you having to manually copy the response from the chat completions endpoint, instead of you manually have to do this, this particular endpoint over here, slash chat endpoint, was maintaining your session, and it was copying the last assistant response and pasting it in the messages object, and then sending it back to the Ollama server. So this is crucial. This is the key, that one of the very important roles of this slash chat endpoint is to maintain this kind of message structure and keep on sending it to Ollama server, right? All right. So this is an example of a simple conversation. So what is a tool called conversation, right? What is it? What does that mean? So if you over here now send a message to a send a user message to the large language model and ask it what is the weather in Woodbury, Minnesota, right? So there is no way large language model can know this answer, right? How would it know this answer? I mean, it can hallucinate, and it can try to generate something, or if it is smart enough, it will say, I do not know. But let's see what it says. It says unavailable. Okay. All right. So at least it is smart enough to tell us that it is unavailable. Let's send the same request again and see if it changes it. It says unstable. All right. Let's send it again 2-3 times and see unknown. So this is a smart large language model. Oh, but nope. See, there you go. Rainy. So it did hallucinate, and it did come up and make up a response back rainy. I live over here. I can tell you for sure it is not raining right now. This is a hallucinated response. Okay, so either it has an option to be smart enough and tell us that it does not know about it, or it can hallucinate and it can make up an answer too. If I ask any question that is not a generic question that it can think of based of its training data, then it is going to come up with something that is most likely a completion of the conversation over here. So if it feels like it can say rainy and that is good enough, then it can hallucinate and respond back like that. Right. So if it does this, let me try to challenge the model, right? So I'm gonna paste this question back over here, and did I not copy it properly? I can finish this from my side. And let me ask this again, something that how do you know this answer? There is no way you can know what the current weather is, right? Let's see what it says. It says uncertain. I think I'll also take away. Uh, you can only respond in one or two words, so it can be a little bit more chatty with us. And let's see if it responds in a better way. There you go. You are correct. I do not have real-time access to external information, including current weather conditions. I'm static knowledge base and cannot provide up-to-date information on weather, right? So now at least it is attempting to say that it cannot provide this information. This is the point I'm trying to make. But in our weather application, if you saw when I was asking for some weather information, when we were doing some request responses over here, uh, or I mean, I'll just leave it over here because it will spike up my GPU, which I don't want. But if you ask it in our weather application, it does have access to weather information. How? How is it going out and telling us the actual weather information in our chat application, but it cannot do that in our direct request response from Ollama? So the reason being, in our chat application, we have provided the large language model with some tools, right? So if you see in this message payload, the only thing that we are adding is model and message. Only two attributes we are adding in the payload. Whereas when we construct the payload for our large language model with some tools access to the large language model, right? Then there will be an extra element over here that we will add, which is what we are going to see next. So there is a basic Ollama function calling example that I want to show you, which looks like this. So in this, if you see, we have a payload of model messages, and we don't need this keep alive. I can delete this for now. We don't need that. Excuse me. So we have model messages and this extra information called tools. What is that? So let's take a look. So let's say that there is a tool that exists that can provide the weather information, right? And let's say that tool is just a simple Python function, right? If you pass a city to that Python function, then it can return the actual value of what the weather conditions are, right? In this case, it is just a sample implementation because implementation doesn't matter. If this was an implementation where you are actually going out to a weather API and getting the data out for the city, then you could have done that. Over here, it is just a mock implementation where it is saying that, yep, whatever the city you are going to provide me, I'm going to say it is sunny, right? So this is the point to focus over here is that there is a get current weather function over here. And this function takes an attribute city as an input, right? And it returns back the value as an output. Now, how do we pass this function to the large language model? So the task that we have at our hand now is that we have an Ollama server over here, and we want our Ollama server to have access to certain tools and to have certain access to certain functions. But functions like this, we cannot have our large language model execute. So how do we do this? The way we do it is we, in our chat completions endpoint, right? So we will, let's make it blank. So we will pass the list of tools. So we will say that, hey, there are a list of tools that you have access to, right? And what are those tools? So those tools are get weather API. But do we pass the actual Python function to large language model? No, we do not. We only pass the definition of the function to the Ollama server, right? So what we say is that, hey, in this chat completions endpoint, we will pass in the message, and we will also pass in tools that this chat has access to, right? So in reality, this tool's access to run stays with the calling application. In this case, the calling application is chat, right? /chat. So your fast API backend server has access to running these tools, but the definition of this tool we will pass to our large language model, to Ollama server, right? So this is what we are going to do. We will structure our payload in a similar way how we have been doing it in the simple example with model and messages, right? All that stays the same. However, we pass in an extra attribute called tools, and this tools is just the definition of the function, right? It is not an actual function. We're just passing the definition of the function. What do I mean by definition of a function? Now let's take a look at that. So in this tools definition, what we pass is that, hey, there is a type function, and this function is get current weather. So the name of the function is get current weather, and the properties of the function is city, which is a string, and the mandatory property is city. Like, you always have to pass in the city to run this. So what we are saying is that, hey, Ollama server, this particular endpoint, when it is making a call to chat completions, it is saying that I have access to a tool, right? It is not saying that Ollama server, you have access to this tool. No, no. When this chat endpoint is making a call to chat completions endpoint, it is telling this that, hey, I am calling you. I have access to this get weather API tool. And if you want to run this tool, then let me know, and I will run this tool on your behalf. This is what this means, right? So once you are formulating your payload, in this payload, you are saying that you, by you, I mean the application who is sending this payload to the large language model has access to these tools. And by the virtue of the fact that you have access to these tools, you can run these tools. But in order for you to run these tools, large language model has to process the natural language, right? So it has to take this natural language and convert this natural language in such a way that you can execute this tool, right? And this is what the function calling means. When I execute this, it will make sense, right? But I wanted to show you that we pass in the definition of the function. So get current weather is the name of the function, right? So we say, hey, the name of the function that the /chat endpoint has access to is get current weather, which is a real function that exists in the Python script. And the properties that it has is city, which is of type string, so it's city, and the required property is also city. So this is a required property. You cannot execute this function without this. And you pass these details to the large language model so that the large language model can in turn format your structure and format the reply such that you'll be able to run this particular method, right? Let's see what that means. So let's run Python 00 basic Ollama example, and let's see. Oh, I forgot to save this, which means it's going to run against the 70 billion parameter model, which is okay. So I'll show you what's going on over here. So it is going to the 11433. Let's see which server I'm hitting. 11434. So it is hitting the all the 4 nodes over here, and here we get the response, right? So it says, so the model response that we got is this. So if you see the role assistant content, none, right? There is no content up until now. Role assistant, so there was a role system and content was whatever, role user content was whatever, and we kept on pasting role assistant content whatever came back from the reply. In this case, there is no content, right? So how would we proceed? Because the model is saying that, hey, there is no way I can tell you the weather data in Woodbury. However, there is something called tool calls, which is part of the message, right? So there's a tool call part of the message which goes all the way till here. And in this tool call, if you see, tool call is an array. It's not one single object, it is an array. So there are multiple tool calls in here. In this case, there is just one tool call, but there can be potentially multiple tool calls over here. So in this scenario, it is saying that, hey, I do not have access to weather, but you have made me aware that you have access to a function called get current weather, which does this thing, which gets the weather data out. So if you run this function, then you would be able to get the data out. And this is the crucial part about it, that the large language model does not run the function. The calling application, which is making the request to the large language model, runs the function, right? So this is the first print that you see over here, which is the response from the large language model. And then after we receive the response, we parse the response. And what do we parse? We parse the choices. So if you see, this is structured in a particular way where you get choices, right? So choices, and then you are getting the first element from there, and then you are extracting the message from there, and then you are extracting the tool calls from there, right? So you are parsing this particular message and you are extracting the tool calls object from there. And once you extract the tool call object, you will start executing the function that is mentioned in this, right? So now over here, because it is a very simple implementation, we have just checked whether the function is get current weather, and if it is, we are just executing the current implementation of get current weather, and then we are printing the value of it, right? So weather in city and weather, right? So weather in Woodbury, Minnesota is, and this is the response from the function implementation. The point I'm trying to make over here is that the same application that called the Ollama server is the application that ran the tool call, right? It is not the Ollama server that ran the tool call. It is the application that made the request. It's the same Python script, right? So application that made the request to the Ollama server did the tool call. And this is the crucial point, that in your application, you are, I mean, the application that is calling Ollama server is this fast API backend server. So /chat endpoint is telling the Ollama server that it has access to a tool. and it is making Ollama server aware of it. So what Ollama server does is it says, okay, I see that you have access to this tool. Why not you run this tool and then give me the result of that information, and then I will tell you what the final outcome is, right? And this is very crucial to understand that once there is a tool called scenario, the user asks a question to assistant by passing in the tool information, right? So this first interaction is user asking what's the weather, and while the user is asking it is passing get weather API information in that request. Assistant is then responding back by saying that, hey, I don't know. The content is empty, right? I don't know the answer to this. However, if you run this tool, right? If you run this particular tool over here, then you can get the answer back. So assistant says that you run the tool, you attach the tool response back to the Ollama server, and then assistant makes its determination, right? And we haven't gone to that level yet. We'll go to that level in the next example. But I wanted to showcase to you that the same application that is doing the request to Ollama server is responsible for executing the function too. There is no way in which the Ollama server can execute the function for you. All right, so let's take a look at this second example where we are doing a request response. However, in this case, we do not have to define the function definition. And this is important also because let me show you. So you define your function over here. And this function's definition, well, you not only define, you also have an implementation, even though it's a mock implementation, but you have a function definition and implementation right here. However, there is this particular definition that you have to write, and it is not easy to write. It is a cumbersome way. And if you mess up somewhere, then you will mess up the whole structure in which the Ollama server understands the tool call, right? So if there is only this way in which the Ollama server will understand that you are having this kind of method in your code. And if you do not structure your function definition in this way for this method, it will break. So this is not a convenient thing to do. Writing this kind of tool structure is not very convenient for us. Is it doable? Yes, but not very convenient. So in order for us to not do this, I'm going to show you an alternative example how you can extract the tool definition dynamically from the actual tool that you have written, right? So let's see that. So in this example, function calling simple example, you will see that there is a tool called get weather tool, which is defined over here. So I'm going to show you this tool, a get weather tool is defined, right? And this tool, get weather tool, takes one input as a city, right? So there is a input in a city state format, and this is a string, and it outputs a string too. So it is written in a very structured format, better than the previous basic example, because in this example, it doesn't matter how you write this over here. The only thing that matters is this tool definition. So you have to be very descriptive and very nice about this tool definition. But if you write your functions in a very structured way, where you give it that what kind of input parameter it is, like in this case, it is a string, and what kind of output you get out of it, which is a string, and then you write a nice doc string over here. So doc string is a definition of this particular function. So you put them in those 3 quotes, and then you write a nice doc string. And in this doc string, you are very clearly saying what the function does. You're also describing a little bit about the arguments and the returns of this function. And then your function implementation, right? Implementation doesn't matter. I mean, in this case, it is a real implementation that goes out to the weather API and extracts the data out. And if you want to see, I can quickly run this particular function. So you'll see exactly what's going on over here. So Python, and in this case, weather tool.py. And this weather tool is trying to get the data from Woodbury, Minnesota. And so you see this is actually reaching out to the weather API, and it is getting the data from there. And if you want to extract the weather data, you can just go sign up for a free account at visualcrossing.com. It gives you 1,000 API calls every day for free, which is more than sufficient for our use cases. I've talked about it in the first video of the series, but yeah. So in this case, this is a very simple implementation of getting the weather data out from an API. And the important point is that we are writing the top part of this, right, up until here, very clearly. Because this is the part that there is something called tool decorator that I will use, which is this custom tool @custom tool. So this tool decorator, what it does is it helps in extracting the function's metadata so that it can structure it in this format, right? So our final objective is to structure the where did it go? There. Our final objective is to structure the function definition in this format without having to write this. If you write your tools doc string, and if you write this properly structure over here, then this tool decorator that I have written will automatically write the function definition for you. And it makes the task very easy, right? So now I do not have to write the tools function definition anymore. All I will do is I will take this tool, I will write it in a separate file or in the same file, doesn't matter, but I can write it in a separate file. I can decorate it with @custom tool. I can import the custom tool over here from this tool decorator. So I'll just keep this tool decorator in my repo in the same project where I have. And in the weather tool, I will import the custom tool and I will decorate with @custom tool. And this particular custom tool annotation will be sufficient, right? So it will be sufficient to extract the tool definition in that JSON format for us. And this is now really, really easy for us to associate our tools with any function implementation. Because in any real world example, you'll be having a separate file where you will keep a list of all of your tools, right? So you have a separate file with list of all the tools you have. All you can do is just keep on annotating them with @custom tool. And then once you are done annotating them, you can just go back to your main program. You can import your weather tool, right? You will import your weather tool, which is weather tool file over here. And the name of the function is get weather. So you will say from weather tool import get weather. And then in your tools array that is supposed to have the function definitions of the tools that you are going to pass to large language model, you will just take this tools array and you will say, hey, get weather dot tool definition. So it will extract the tool definition from here. And how does it do that? Because you have annotated it with @custom tool, right? Okay, so now that you can do that, now let's run this example and let's get the answer back from the large language model, right? So let's go over here and let's do Python 01 function calling simple, and let's hit send. So now it is going to, oh, it will use the 70 billion parameter model again, which means it is going to take some time to load in the system memory over here. And in a couple seconds, when it is done loading, we'll be able to see the response back. So just give it a couple seconds. Once the model is all loaded, we will see the response back. There we go. Okay, now the model is loaded, and there we go. we get the response back. Okay, so if you see, we asked what's the weather in Minneapolis, and the response that we got back was again, assistant said content up, I don't know the weather. However, there's a tool call, and it sent the tool call back. And the tool call was function name get weather, right? So even though we did not describe the function definition, we actually did pass the function definition because we extracted it from our get weather function by annotating it with @custom tool, right? So we passed in our model messages, tools, and the tools had the function definition which we extracted from the @custom annotation, right? We use @custom annotation to extract the function definition. And I want to make this point very clear because going forward, we have two ways of providing the function definition to large language model. Way one is where you can write this by your hands, and that's okay. You can choose to write this, or you can one time write a tool decorator that can extract the tool definition dynamically from your tools, which is what we'll be doing going forward. All right, so there is another example that I wanted to show you, a little bit more complex example, where we are taking the large language model's inputs and we are passing it back into the large language model, right? So we are taking the inputs from the large language model, we are processing it, and then we are sending it back to the large language model. And this example that I'm talking about is this scenario where the user sends a request to assistant. Assistant says that, hey, in order for you to know the answer, you have to run a particular tool. You run the tool, and then you pass the information back to the assistant, and then assistant makes use of that information and then gives you the answer back, which is what we will see over here in this example. So in this example, if you see, we are doing the same thing. We are importing the weather tool, right? We are importing the get weather from this weather tool.py file. We are extracting the function definition over here. And then from this function definition, we are passing it. So we have tools, models, messages. We are creating a payload over here. The payload has model, messages, and tools. Keep alive is just something that doesn't let the model kick out from the memory. I'll have to double check because my model is getting kicked out anyway. So I don't think this parameter is working. But what the first three attributes are your model that you want to use. In our case, it is 70 billion parameter model. Messages, which is this thing that we have constructed with system and user role. And the tools, which is the list of functions that we think that we can run and we want model to be aware of, right? So in this case, we are saying that, hey, is it hotter in New Delhi or Minneapolis, right? So it's not just one city now. We have given two cities. So I'm hoping that the model will say that you need to run this weather API twice, right? One for Minneapolis and one for New Delhi. See, in the last example, it only gave us tool calls was an array, yes, but there was only one single input in that array, right? One single attribute, sorry, in that array. And that attribute, one attribute was run the get weather API with arguments of Minneapolis. But in this time around, we are asking which is hotter. So we are asking it to make a comparison. So let me, run this, and then I will keep on talking in the background. So Python 02 function calling LLM feedback. Okay, so now once we get the response back from large language model, we process the response by doing the actual tool calls, right? So if you see, what we are doing is we are checking whether we have a get weather call in there, and if we do, we are actually looping over the tool calls that we get back from the large language model, right? So we get tool calls that we have extracted out. So let me go back over here. So we have tool calls that we have extracted out. I'm not printing it, so that is why we cannot see it. Maybe I should just print it over here too. Response data over here. So let me do that. Print response data, and let me run this again. What this will do is it will show you the response data, and then it will show you the actual function call. So when we ask this question, which is hotter, New Delhi or Minneapolis, we send this along with the tools that we have available to run. We send this to the large language model and to Ollama server essentially. And the Ollama server returned us back a response, which is this response data. So this is what Ollama server returned back to us. It said that, hey, assistant, role assistant, content, nothing. I do not know the answer. That's what it is saying. However, if you run this tool call, then there is an array that I'm providing you, right? There's an array. In this array, there are two tool calls. One tool call has an ID of this, and second tool call has an ID of this. The first tool call is saying that run the function called getWeather with the arguments of New Delhi. And the second tool call is run the function called getWeather with the arguments of location Minneapolis, right? So there are two elements, attributes, whatever you want to call them, in this particular tool calls array. Now, in our code, we are looping over these two. We are saying that, hey, for call in tool calls, there could be multiple of those, which there are. There's one for New Delhi and another one for Minneapolis. We're going to loop over this, and we will see if there is a getWeather function in there. And if there is, we will call the getWeather function with the arguments that the large language model has identified, right? So if you see, we just said New Delhi and Minneapolis, but the large language model changed it to New Delhi, India, and Minneapolis, Minnesota, right? So this is the input that it wants us to pass to the actual weather API. So which is what it is doing. We are passing the input and then we are printing the answer from there, right? So we are passing the input and then now we are printing the answer from the first API and then printing the answer, well, up until here. So this is the weather in New Delhi, printing the answer from the first API and then answer from the second API over here. And after we are done with that, we construct a tool messages response and we append it, to tool message. So every single tool message response is constructed and it is appended to an empty tool messages array that we have created on the top. Right? So there is an empty tool messages array. In this loop, we are constructing, running each and every tool message, and then we are saying role is tool, content is the actual content that we got back from running the tool over here, and then we are appending it to tool messages. And then this tool messages, we will then append it to our main list of messages, right? So on the top, we had this list of messages which had system and user. Now we are also going to append these tools into that, right? So we're going to append the tools as well. And then we are going to construct our payload now. So our payload has messages which had previous messages plus tools response in there now, right? So if you go back over here, we have system, user, assistant, and then we have added the tool message back to it. And now we are going to send this whole thing back to the large language model. So let's see this. We have constructed our payload and we are going to send it back to large language model. And this is the final response that we will get back, right? So let's see. The final response that we get back is this. Assistant, role assistant, it is not saying content empty anymore, right? If you see previously, it said content empty, but it is not saying content empty anymore because it can take a look at the tools that you have, tool responses that you have passed. And it is saying it is currently hotter in New Delhi than in Minneapolis, with a current weather of 87.9 as compared to 66.7 in Minneapolis, right? So it is able to take a look at the tool responses, analyze the tool responses, and then give us a smart reply back. And this is what we are utilizing in our chat application too. So in our chat application, what we are doing is we are making a request to the fast API backend server. This fast API server slash chat endpoint is then in turn making a request to Ollama server. When it is making a request to Ollama server, it is telling it that, hey, I'm not a dumb endpoint. I'm a smart endpoint. I have access to these 5 different tools, right? I have access to get weather API. I have access to run internet search using DuckDuckGo. I have access to run internet search using the CRX NG. I have access to look up Wikipedia information, right? So there are 4 different tools that I have access to. And if you feel like you do not know an answer to a question that I'm asking you, Ollama server, right? So this is what chat endpoint is telling it. If you feel like you do not know the answer to the questions I'm asking you, then do not hallucinate. You can tell me you don't know the answer, but as a response, tell me which tools I can execute to get that answer for you. And I will execute those tools, give you those answers, and then you will have to in turn analyze those answers and then give me the smart reply back. This is what function calling means, or tool calling means, end to end. The point to understand over here is Ollama server does not call tools. Ollama server just tells your calling application which tools to call. Calling application then calls the tools. Then calling application formulates the messages for the Ollama server. It sends those messages back in the tool response. And then the Ollama server gives you the final assistant response back. And this is how we do our function calling or tool calling. And then there is a last example over here, which I have created so that it looks clear, concise, and you can see every request and responses going back and forth in a very nice, colorful manner. So if you run Python 03 function calling advanced, so over here, your code will actually stop at multiple junctions and it will ask you to hit enter to proceed. But you can see all the requests and responses that go through. So very initial payload that you have is your model, your messages, a system message over here, and a user role message over here, right? And this is where your messages end. The tools, you pass in a tools description. So you notice that in your code, you have not written this description, right? There is nowhere in the code that you have written this tools description. However, because you are using getWeather.tool definition, this is extracted for you. This is being created dynamically for you. You did not have to write this. Otherwise, this is required for you to write this, but you did not have to write it because this helper method over here creates it dynamically for you. If you hit enter and you send the initial request to AI model, then the AI model will process this request. And let's see, once it loads, once the model loads completely in the memory, it will process the request and it will not run the tools, but it will give you the suggestion to run the tools. Right? So let's wait for it to give us the response back. And this is where I was saying that the keep alive is not working for me. Right now, that keep alive attribute, it gets unloaded from my memory every time. But it should be loaded now. It takes like a few seconds to load. It's loaded now. It's running, executing. And there is the response, right? So this is the response from the large language model. Initial response says that content is none, right? So role assistant, content, nothing. I do not know. I do not know the answer to your question. But if you run this particular get weather tool with New Delhi, and if you run with the get weather tool with Minneapolis, right? If you run these 2 tool calls and you send me the response back, then I will be able to give you the data. So you do that, then you proceed with the 2 tool calls, and those 2 tool calls give you the answer back. And now you are going to generate your final request payload, right? You haven't sent the response request back to the Ollama server. So you are at this point where you have received the first response from assistant where it has asked you to run two tools. You have run those two tools, and now you are generating the next request for the large language model over here at this point. So hitting enter, and let's take a look at that request. In this request, you're continuing the conversation, system, user, and then you have this tool, right? So you're associating the tools to the messages, and you are saying that, hey, these are the two tools. If we run, then you will, I have run, not if we run. These are the two tools that I have run, and here is the data for you. And now you go large language model, and now you respond back more smartly to that question. And if I hit enter over here, the large language model will now have the capability to answer back because it has the data from tools, right? So it says the current temperature in New Delhi is this, and in Minneapolis is this. Comparing these two cities, it is clear that New Delhi is hotter than Minneapolis. And this is one of the most important aspects of our application, how we are doing the tool call. Understanding this is very important for our application. So I highly recommend going through this video again. If you have any confusion, running all this in your local, understanding how tool calls are being done, understanding how the message responses are being constructed, and how this chat endpoint actually, which in our case, we are just simulating it as a local method over here, right? So we are just one Python script is doing everything for you. But in our main, once we go back in the next video and take a look at /chat endpoint, this is what is happening over there, where the /chat endpoint is building this messages object per session value from the browser, right? So for one session, it is building messages object for that user. If you open a new browser window and send a request, then it is building a separate session and messages object for that user. And this is the important point over here. All right, so this is where I would like to end this video. Please watch the whole series. If you have any questions, please let me know. If you'd like to see me focus on any particular aspect, or if I'm over explaining certain things, then please let me know that too. And if you are all the way up until this point and still watching, then please let me know what else you would like to see in terms of applications that I can build for demonstrating the capabilities of large language models, right? So I already have a Jarvis concept in my mind that I have built. It is half-baked. I have showcased that, but there are more features that I want to add to it before I can release the whole source code to it. But if you would like to see anything special, do let me know. Thank you everyone for watching, and I'll see you guys in the next video where I'll explain more details of how our chat-based AI application is working. Thank you.